Hi all. In previous video lecture, I explained what are the parts equations you can focus initially and how to cover the subject. Right now, in this video lecture, I am going to explain how to learn the subject. Right. So if you are considering some part A question or sorry, part C question, how to learn it. So part C. In part C, the question may be either derivative, right? It may be some derivation. Mostly it will be derivation, right? It will be derivation, or it may be some theory, or it may be some differences between two, right? So the questions can be like this, right? Questions can be like this. And these questions, mostly it will be PL3 and PL4, right? This is apply and this is analyze. The question concept will be uh, this knowledge level, VL3 level or VL4 level. Okay, so the questions will be asked like this, then how to answer and or how to prepare this first of all, then how to answer. The first preparation, right? For example, if you take derivation, how derivation can be prepared. So derivation, so many of them, they blindly memorize the derivation, right? Blind memorize, right? Most of them do this process. No use. This is absolutely wrong method, right? Wrong method. If you blindly memorize the expression, you definitely will forget. You cannot simply answer this question. If you want to derive and if you want to derive continuously without any hindrance, first thing you should understand the core concept core concept. I'll take an example so that will be easy for you to understand. For example, let me take density of energy states. Density of energy states. Or if you find any particular topic is difficult, I can even explain with that. So why this density of energy states? Most of them uh, they find it very difficult. So I'm taking this. So what is the core concept? Density of energy states, the definition you need to write. It is nothing but the number of energy levels, per unit volume, per unit volume. That is density of energy states. So what is the core concept? We need to determine the number of energy levels within an energy interval E and E plus DE, right? Within energy interval E and E plus DE. And that has to be divided by the volume. Okay, this is the core concept. For that, we consider the material. We make an assumption that the material is a cubic material. The metal piece, whatever we consider, is a cubic metal piece with a side length A. And in this, we construct imaginary sphere. The sphere represents the energy level E. And I consider another energy level, another sphere, which is E plus DE, E plus DE. So the number of energy levels between these two will get you the number of energy levels between E and E plus DE. That's it. So this is a core concept, this is a core idea. We need to determine the number of energy levels. We need to find out what is the volume. And to determine the number of energy levels, we construct two imaginary spheres, which is not originally present there, and find the number of the such spheres between that. That will lead to the determination of the number of energy levels, in turn, density of energy states. This is the core concept. What I'm going to do. I'm not talking about how I'm going to do, what I'm going to do, what I'm going to derive. That is the core idea. This core idea, without this core idea, nothing can be done. Any question I can tell this. For example, if you take intrinsic charge carrier concentration. In intrinsic charge carrier concentration, what is the core idea? The core idea is to determine the density of electrons in conduction band level, EC to plus infinite in this level, and minus infinite to EV, density of holes in this, number of holes in this per unit volume. So, and how this is created, that and all you need to explain. The core concept is we need to determine the density of electrons in conduction band level and density of holes in valence band level. And for that, what we are going to do? For that, we are going to use density of energy states is at EdE and Fermi function f of E. Okay, so these things are the core concept. Like that, any question you ask, definitely I can able to say what is the core concept. I'm not going to derive it. I just say what we are going to do. That is the core idea. Without knowing the core idea, you cannot derive. And then the second thing what is required is the process. What are the process that involved? For example, in determination of density of energy states, what is the first process I say? Is that EdE is equal to N of EdE divided by volume, right? First step is you have to determine N of EdE. To determine N of EdE, we construct two imaginary sphere. It construct to imaginary sphere. And second, what I'm going to do is I'm going to calculate volume within the sphere of radius n. And similarly, I'm going to determine the volume n plus dn. So I'm going to calculate volume within sphere of radius n. What is the second thing I'm going to do? Volume within sphere of radius n plus dn. So this I need to determine. I need to find out this. Right? What is the volume? All right, because each volume, 1 unit volume represent one energy level. I make an assumption 1 unit volume is equal to one energy level. So whatever be the volume is equal to the number of energy levels. So I find out this volume and this volume, and I just subtract these two volumes to get the in between energy level. But energy levels, right? So we know that we cannot take the whole volume. However, we cannot take the whole volume because we know nx, and definitely this will be minus x, minus nx, and this is ny, and definitely this will be minus ny. So n is at minus nx. We need only one octant because only in one octant all the three values will be positive. This n is principal quantum number which cannot be a negative. It should be a positive integer. Only 1/2 of the 1/8 of the whole sphere having that value. All the three values are positive, x, y, z, since it is a three-dimensional object. So in that case, we cannot take the whole volume. We can take 1/8 of the volume in order to calculate the number of energy levels. And then I incorporate one concept, right? Because E is equal to n square, h square by 8ma square. In between, in order to determine the value of n and n plus dn, I have to use this idea, which I learned in particle one-dimensional box. Okay. And then what I'm going to do, next I'm going to, next thing I'm going to, sorry, I'm going to simplify that. While during simplification, I'll be multiply that value by multiply by 2 in order to satisfy Pauli exclusion principle. Exclusion principle. right? In order to satisfy Pauli's exclusion principle, right? And later on, we can get the value as 4 pi by h cube to m power 3 by 2 to e power 1 by 2 into dE. So simply this is the process. First, what I did, I just calculated the volume and just subtracted it and then multiplied by 2 in order to satisfy Pauli's exclusion principle after solving that. So this is the idea. If you know the idea, you can derive. Even as a teaching staff, I do not know all the equations in between. I know the first, where it starts, what are the processes involved. I know only the final. This is the way to derive expression. Okay. And the theory. So theory, you can make a comparative study if it is similar topics. For example, domain theory of ferromagnetism, domain theory of hysteresis, very similar. You can make a comparative. In domain theory of ferromagnetism, we explain this closure domain and magnetization, where here we talk about domain wall movement, domain wall rotation. In hysteresis, what is that? Like that, if you have a comparative statement, it's easy to learn. And the theory have much advantage as well as disadvantage. The advantage is if you understand the concept, definitely you can able to answer it. For example, metallic glasses. If you know about what is metallic glasses, metals plus glass, right? Glass structure, this metallic glass, which means the glass means amorphous structure, which is equal to metallic glass. And we should know about what is the types. We should know what is the properties. You should know what is the applications, right? So these are the concepts. Very simple. In the types, metallic. Properties, rectangular close pack, corrosion resistance, lightweight. So application, it can be used in nuclear fuel disposal and can be used as razor blades, medical instrumentation. So like that, we can list out quite easily. Easy to learn. If you understand the concepts, definitely you can answer. That is not much difficult. So this is the way of preparing theory, right? So with this, I'll stop here. And the other topics in other units, I just brief it in the next lecture.